Ever wonder how all the tech in our lives, our phones, laptops, even like all those smart gadgets we can't live without, how it actually works?
It's pretty amazing, right?
It really is. But it all starts with these, well, crazy, intricate circuit boards.
Yeah.
But designing them, that's got to be a real challenge.
Oh,
Like a
absolutely.
microscopic game of Tetris.
That's a good way to put it, with like a million rules, though.
And no room for error.
Exactly. Exactly. We're talking PCB placement.
PCB placement.
Yeah, so figuring out where to put every single component on a circuit board. And today we're diving into some cutting-edge research. It's from the ASPDAC 25 conference
Okay.
about a system called a PCBAgent, which uses AI to try and make this whole process a little bit easier.
PCBAgent.
Yeah,
Okay, it sounds like a secret agent for circuit boards.
it does. It does.
So tell me, what makes PCB placement such a brain twister?
I mean, you got to imagine trying to fit hundreds of tiny components onto a board, like the size of your hand, and making sure none of them overlap. The research paper lays out some pretty strict rules. No overlapping.
Okay.
Got to stay within the boundaries of the board and keep the right amount of space between components.
Oh, so it's not just squeezing everything in.
No, no.
It's about precision.
It's about precision, following the rules.
Yeah?
Exactly.
Okay.
And one of the biggest challenges is just the sheer density of these boards.
Okay.
The paper mentions that PCBs can be up to 76% dense,
Wow.
which means almost the entire board is covered in components.
76%. That's a lot to cram into a small space.
Oh, yeah.
Is that why it's so much harder than, say, designing a computer chip?
That's a big part of it. Computer chips are laid out on a neat grid, right?
Right.
PCBs have components of all shapes and sizes.
Oh, okay.
And each with its own spacing requirements. It's like solving a jigsaw puzzle,
Yeah.
where every piece is a different size.
Right.
And some pieces need, like, extra breathing room.
So consistency is key. Especially, when you think about manufacturing thousands of these boards.
Oh, yeah.
Even small variations.
Huge headaches.
Yeah, it could cause major headaches.
For sure. And there's another layer of complexity, literally.
Oh, okay.
It's not just about placing the components, it's also how they connect.
Okay, I'm intrigued. Tell me more.
So this paper dives into something called surface layer wire, or SLW.
SLW.
Yeah, think of it as a wire running on the top layer of the board.
Okay.
Ideally, you want as many of these as possible,
Okay.
running cleanly without crossing over anything.
So more surface layer wires, the better.
The better, yeah.
But why?
Think of it this way. More SLWs means fewer layers are needed in the PCB overall,
Okay.
which makes it cheaper to produce,
Gotcha.
and often leads to better performance.
That makes sense.
It's like building a house. The fewer floors you have,
Simpler.
the simpler and less expensive.
Right.
Exactly.
Okay, so I'm guessing there's a catch.
There's always a catch.
Yeah.
You're right. The challenge is maximizing those SLWs while also keeping the overall wire length as short as possible.
Okay.
Longer wires, those can slow down signals and cause other problems.
Gotcha. So it's a balancing act.
It is.
Trying to fit everything in, keep the wire short,
Yep.
maximize those SLWs.
It's a lot to juggle.
Sounds like a job for a supercomputer.
Or maybe PCBAgent.
Yeah, PCBAgent. So that's where this research gets really interesting.
This is where it gets really cool.
Okay.
PCBAgent uses two different AI agents to tackle this problem, like a dynamic duo for circuit board design.
2 AI agents.
Yeah.
Okay, tell me about these partners in crime.
So one is called the RL agent,
Okay.
and it uses a technique called reinforcement learning, which is basically like trial and error, but supercharged.
Trial and error with the supercomputer brain?
Exactly.
I like it. Okay, what about the other agent?
So the other one is the LM agent, which stands for Large Language Model Agent.
Okay.
This one's all about understanding feedback from human engineers
Okay.
and using that to guide the RL agent towards better solutions.
So it's like having an AI translator
Yeah.
that can understand what the engineers want and tell the RL agent how to make it happen.
Exactly, you got it. And this combination of two AI approaches, that's what makes PCBAgent so unique.
Right.
It's like having the best of both worlds, the brute force of reinforcement learning and the understanding of human feedback.
Okay, I'm starting to see the potential here. But how does this AI duo actually go about designing a circuit board?
Well, it all starts with what they call a state token,
A state token.
which is basically a snapshot of the circuit board at each step of the placement process. Think of it like taking a picture of the board as it's being built.
So the AI is constantly checking its progress,
Yeah.
making sure everything's in the right place.
Exactly.
What happens next?
All right, so next, PCBAgent uses a system of masks to analyze and make decisions about where to place the next component.
Masks.
It's like having different filters that help the AI see the board in different ways.
Filters for a circuit board? That's pretty clever.
Yeah, it's a really interesting approach.
Yeah, so these masks, they help guide the AI's decisions.
That's right. They help it figure out which placements are legal, efficient, and meet all the requirements.
So unlike a human engineer,
Right.
PCBAgent can see all these different factors simultaneously.
That's the advantage.
Yeah, that seems like a huge advantage.
It is.
Okay.
And another key aspect is that PCBAgent uses a chip-centered approach to placement.
Chip centers.
Instead of placing components randomly, it starts by placing the chips first,
Okay.
which are often the biggest and most complex parts.
Why does that make sense?
Well, chips usually have the most connections.
Right.
So by placing them first,
Okay.
PCBAgent can then arrange the other components based on their connection to the chips.
It's like placing the cornerstone of a building first.
Perfect analogy.
Right, yeah.
And along the way, PCBAgent uses some clever optimization tricks to make the layout even better, so encouraging neat rows of collections, to maximize those SLWs and make sure components are just far enough apart to meet the spacing rules.
So it's not just about following the rules.
No.
It's about finding the best possible solution within those rules.
Exactly. That's the goal.
Okay, this all sounds really impressive in theory,
Yeah.
but does it actually work?
That's the million-dollar question, right?
Yeah.
And based on the results in this paper, the answer is a resounding yes. So the researchers, they tested PCBAgent on 17 real-world PCB designs.
Okay, 17.
And the results are pretty remarkable.
All right, I'm all ears. Did PCBAgent pass the test?
It passed with flying colors. First off, it was able to create layouts that met all the requirements for every single test case.
Oh, wow. Okay.
Which is something other methods struggled with,
Yeah.
especially on those densely packed boards.
Right.
So it's reliable.
This gets the job done.
It gets the job done. But how did it stack up against human experts, right?
Well, that's the ultimate test.
That's the ultimate test.
Could it match, like, their skill and intuition?
Yeah, that's a great question. And surprisingly, PCBAgent got within 10% of human performance on average.
10%? That's incredibly close.
It's really impressive.
I'm impressed. Did any particular benchmark stand out?
Yeah, one that really caught my eye was task 12.
Okay.
This particular design had a density of 76%.
Wow.
Remember, that's like trying to fit all your belongings into a tiny suitcase.
Yeah, I can barely manage that with a normal-sized suitcase.
Exactly.
Yeah.
But even with that insane density, PCBAgent, not only did it produce a legal layout,
Yeah.
but it also achieved a really low HPWL, which is short for half pyramidal wire length. It's basically a measure of how much wiring is needed to connect all the components.
So lower HPWL means shorter wires, which is good for performance, right?
Exactly. Shorter wires, better performance. And it also managed to squeeze in a high number of those surface layer wires, those SLWs we talked about.
Okay, so PCBAgent is good at following the rules.
Yes.
Optimizing for efficiency, and even handling those incredibly dense designs.
It does it all.
But PCB design isn't just about numbers and algorithms, is it?
That's a great point. You're absolutely right.
There's a human element involved.
There is,
as well.
for sure. And that's where PCBAgent's LLM agent really shines.
Okay, remind me again what's so special about the LLM agent.
So the LLM agent, remember, is all about understanding human language and feedback.
Right.
It allows engineers to give instructions and refine the AI's output using plain English.
So they don't have to, like, learn any complicated code or programming language?
No coding required.
That's good.
The LLM agent acts as a translator, bridging the gap between human instructions and the AI's actions.
Can you give me, like, an example of how this feedback loop might work in practice?
Absolutely. So let's say an engineer is working on a board where those surface layer wires are particularly important for a specific component,
Okay.
like a capacitor. The engineer could simply tell the LLM agent, hey, I need as many SLWs as possible for these capacitors.
Then the LLM agent would understand that
It would.
and tell the RL agent to make it happen.
Precisely. And the paper actually shows that this feedback loop can significantly increase the number of SLWs over multiple rounds.
So it's like having an AI assistant
It is.
that not only designs the circuit board,
Right.
but also learns from your preferences.
Learns and adapts. That's the key.
That's really cool.
It's a pretty powerful tool.
So we've seen how PCBAgent tackles the placement challenge,
Right.
how it optimizes for things like wire length and SLWs,
Yep.
and even how it incorporates, human feedback.
It's the whole package.
So what's the big takeaway here? What does this all mean?
I think the biggest takeaway is that this research represents a major step towards automating a process that's traditionally been very time-consuming and complex.
Yeah, it sounds like it.
PCBAgent could dramatically speed up design cycles
Okay.
and potentially make electronics cheaper to produce.
Faster design cycles, cheaper electronics. That's a win-win
I think so.
for everyone.
For everyone, yeah.
Oh, the paper only focuses on component placement, right? What about the actual wiring?
Yeah.
Figuring out the paths for all those connections.
The routing.
That seems like a whole other challenge.
It is, you're right. The routing phase of PCB design, it's just as complex, if not more so.
Yeah.
But imagine if we could combine PCBAgent's placement capabilities with an equally powerful AI system for routing.
That's a fascinating thought. Could we be on the verge of fully automated PCB design?
It's definitely a possibility.
Wow.
And if that becomes a reality, think about the implications.
Okay, let's explore those implications for a minute.
Right.
What could this mean for the future of electronics?
Well, for starters, it could democratize the design process. Imagine a world where anyone with an idea for a new gadget could bring it to life without needing a team of engineers and months of development time.
That's an exciting thought.
Hmm.
It could open up a wave of innovation, allowing individuals and small businesses to create devices that were previously out of reach.
Exactly. And it could also push the boundaries of what's possible. Imagine being able to design incredibly complex and powerful devices that were simply too difficult or time-consuming to create using traditional methods.
So we're talking about, like, not just faster and cheaper electronics, but potentially a whole new generation of devices
Yeah.
that could revolutionize industries and change the way we live.
It's a future filled with possibilities.
But, with any powerful technology, there are always, potential downsides to consider.
Oh, of course, of course.
What concerns come to mind as you think about this potential future?
Well, one concern that often comes up with automation is the impact on jobs.
Right.
If AI systems can design circuit boards, what happens to the human engineers who currently do that work?
Yeah, it's a valid concern. But perhaps instead of replacing human engineers entirely,
Yeah.
AI could free them up to focus on, higher level tasks,
Yeah.
like the more creative and strategic aspects of design
Right.
that
Yeah.
AI might not be able to replicate.
That's a great point. It's about augmenting human capabilities, not replacing them entirely.
And it's also important to remember that even with advanced AI tools, there's always a need for human oversight, right? You
Absolutely.
need engineers who can understand these systems, interpret their output, and make sure they align with, real-world needs and safety standards.
Couldn't agree more.
So we've explored this exciting new development in AI-powered design, PCBAgent, and we've delved into the potential impact it could have on the future of electronics. It's clear that this technology has the power to transform the industry.
It really does.
But it's also crucial to consider the potential downsides and make sure we're using this power responsibly.
I completely agree. It's an exciting time to be witnessing these advancements, but it's also a time for careful consideration and thoughtful discussion about how we want to shape the future of technology.
Sounds like we're on the brink of a real paradigm shift in electronics design.
I think so, yeah. And just like with any major technological leap, there will be challenges and those unexpected consequences. But the potential benefits are truly remarkable.
Yeah, it's a lot to think about. So to bring it back to our everyday lives, what does all of this mean for, like, the average person? Will we see these changes reflected in, the devices we use every day?
Absolutely, yeah. Faster design cycles and lower production costs. I mean, that
Yeah.
could translate to like cheaper and more readily available electronics for everyone, right? We might see a whole new wave of innovative gadgets hit the market, things we haven't even imagined yet.
That's what always gets me excited about these kinds of breakthroughs. It's not just about those incremental improvements.
Mm.
It's about opening up entirely new possibilities. Maybe someday we'll be able to, design and create our own, like, personalized gadgets at home.
That's not as far-fetched as it sounds. Just think about how 3D printing has evolved from a niche technology to something that's becoming increasingly accessible to consumers. We might see a similar trend with electronics design,
Yeah.
where these powerful AI tools, they empower individuals to become creators.
I can't wait to see what the future holds. This PCB agent system is just one example of how AI is, like, transforming the world of design. I bet there are countless other innovations happening right now, innovations that we haven't even heard of yet.
Oh, there definitely are. It's an incredibly dynamic field. And as these AI systems become, more sophisticated and accessible, who knows what amazing creations we'll be able to bring to life.
Well, on that note of boundless possibilities, I think it's time to wrap up our deep dive.
It's been fun.
We explored the intricate world of PCB design, learned about PCB Agent and its innovative approach to component placement, and even pondered the potential impact of AI on the future of electronics.
Yeah, it's been a fascinating conversation.
And for our listeners, I hope this deep dive has sparked your curiosity and left you with some food for thought. Keep an eye on this space because the world of electronics is evolving rapidly, and AI is playing a major role in shaping its future.
And who knows, maybe one of our listeners will be the one to create the next groundbreaking gadget powered by the magic of AI.
That's a great thought to end on. Thanks for joining me on this deep dive. It's been a pleasure exploring this topic with you.
The pleasure was all mine.